Hello everyone, nice to meet you. I'm Fatah Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain Cambridge O-Level Chemistry Paper 2 Theory 2 variant October-November 2023. Let's get started. This paper is having 1 hour 45 minute duration and basically it is of 80 marks paper. Question number 1, choose from the list of compound to answer this question. Ammonia, ethanol, glucose, magnesium chloride, magnesium oxide, methane, nitrogen dioxide, phosphorus 5 chloride, polyethylene, sodium bromide, water. Each compound may be used once, more than once, or not at all. Identify the compound that A is a waste gas from the digestion in animals, the methane gas. Basically, methane is formed from the vegetable decay and it may be formed from the cow or the pig manure or the marshes, etc. etc. So, methane is the correct option. So, the first answer is methane. Methane, I mean CH4. B, a compound that turns cobalt 2 chloride pink. It's a property of water that water turns cobalt 2 chloride pink. So it's a test of water basically. React with ethene above 100 degrees Celsius to make ethanol. So which one is supposed to react with ethene to make ethanol at 100 degrees Celsius? Obviously it's a steam. I mean basically here there is no option of steam, there is only one option, that is water. So it answer will be the water. D, compound is the product of photosynthesis. What is formed during the course of photosynthesis? You know, there is a synthesis of glucose, sugar basically, and here is the option, yes, glucose. So I'm going to write glucose. E contains anion with charge of 2 negative. So it must be an ionic compound in which the charge should be equal to -2. Mg is magnesium, group 2 element, it is having +2. And chlorine belong to group 7 element, it is having -1. Magnesium again +2, but oxide it belongs to group number 6. So it's making -2 oxidation state or 2 minus charge, I mean. So what is the answer? The answer is magnesium oxide. So the answer is magnesium oxide. That's all about question number 1. Come toward question number 2. This question is about metal. Chromium is a transition element. Sodium is an element in group 1 of the periodic table. State 2 physical properties of the chromium that are different to those of the sodium. So they are asking the unique physical properties of the transition metal. Those are different from the group 1 metals or group 1 element. Basically, the physical properties are the melting point, boiling point, density, volatility, malleability, and so on. So number 1, you know, transition elements are hard. They are having high density. So number 1, they are hard, they are malleable, they are having high density, and they are having high melting and high boiling point. So number 1, high melting points at the boiling point. So one is same thing. Melting point or the boiling point, both are counted as a one property. Now the next property is basically they are having high density, right? High density. You should memorize the list of physical properties. I mean, melting point, density, volatility, malleability, electrical conductivity, and solubility. And here are the two different unique physical properties. Part B, deduce the number of proton and neutron in chromium atom as shown over here. The smallest number is basically it's a proton number, or it is written as or represented as Z with Z, and it is number of proton 24. In this case, what is this number? This number is the atomic mass, and from here we can find the number of neutrons. So higher number minus smaller number is equal to the number of neutrons, that is 29 over here. And so it's a proton number, this is the neutron number, and so on. So number of proton is equal to 24 and number of neutron is equal to 29. Part C, chromium 3 oxide Cr2O3 react with carbon and chlorine to produce chromium 3 chloride and carbon monoxide. Construct a simple equation for this reaction. So Cr2O3 react with just carbon and chlorine Cl2 goes to make chromium 3 chloride CrCl3. Obviously it will be in 2 mole because we are having 2 chromium atom over here, plus carbon monoxide will be there, and obviously it will be 3 mole of CO because 3 oxygens are over here. Now to balance the Cl here, Cl is equal to 6. I'm putting 3 over here and 3 over here for the sake of balancing of carbon atom. So this is the balanced chemical equation, and it is correct answer as well. D, complete the diagram in figure 2.1 to show the electronic configuration of sodium ion. Include the charge on ion. Sodium ion, you know, is belonging to the group number 1, so its charge will be 1 positive or 1 plus charge. And initially in first shell, that is a K shell, it is having 2 electron. In second shell, it is going to have basically 8 electron. It is going to have 8 electron, so it is having complete octet, and it is having plus 1 charge over here. So that is the complete or exact description. Question E, table 2.1 shows observation made when 4 different metals are heated in oxygen, and metal observation, lanthanum, mercury, nickel, sodium, and here is the list of observation, and put the 4 metals in order of their activity, put the least active metal at the first and the most active metal at the end, I mean. So first of all, lanthanum form a layer of oxide rapidly on the surface but does not burn. Okay, the mercury does not form a layer of oxide on the surface. Nickel form a layer of oxide surface very slowly on the surface but doesn't burn, and sodium burns rapidly. So the first thing is, which is burning, mean it is highly reactive towards air, mean oxygen. There is only one gas, that is oxygen, in the air that can react, that can show chemical reaction. So sodium burns rapidly. I mean, sodium react with oxygen rapidly, vigorously. So it means that the highest metal, highest active metal, the most active metal is sodium. So this is a sodium. Then the next one, which react with the oxide rapidly on the surface, this layer, making the layer of oxide, but it doesn't burn, then it will be lanthanum. And That's lanthanum. That is the second reactant. Does not form a layer of oxide, form oxide layer very slowly. Then, that is the next most reactive element. So it is nickel. And the last one, obviously, it will be mercury. If aluminum is used in food containers and overhead electrical cables because it is resistant to the corrosion. Explain why aluminum is resistant to corrosion. The typical answer is aluminum reacts with oxygen to form an oxide coating, and this coating is inert. It stops the reaction of metal with oxygen. So aluminum form an oxide coating on it. When it reacts with oxygen. On reaction with oxygen. On reaction with oxygen. And this coating is inert. And this oxide coating is inert. It's not going to react further with oxygen basically. So that is the basic reason. Second part, state two other reasons why aluminum is used in overhead cables, overhead electrical cables. Number one, it's a good conductor of electricity, as you know. Good conductivity is the basic reason. It's a good conductor of electricity. And the second one reason is it is lighter, basically light in weight, or it is having low density. So that's all about question number 2. Now come towards question number 3. A student investigates the reaction of large pieces of calcium carbonate with dilute hydrochloric acid. The hydrochloric acid is in excess. Complete the equation for this reaction by adding state symbols. Calcium carbonate, it's water insoluble, so I'm going to put S over here. 4 state symbols are over here. S for solid, L for liquid, G for gas, AQ for aqueous. HCl is insoluble, so I'm going to write aqueous. H2O is a liquid, it's a pure compound, it's liquid basically, and it is not supposed to be very soluble in water, so small l for the liquid of H2O. B part. This figure 3.1 shows the volume of CO2 carbon dioxide gas released as the reaction proceeds. So what is the next part? The next part is deduce the volume of CO2 gas released after 40 seconds. Here is the time, and on vertical axis, y-axis, the volume. Overall, you can see that this is the volume of the gas at 40 seconds. So here is the volume, here's the answer of the gas, and that is equal to 34. So the volume is equal to 34 centimeters. The student repeats the experiment using the same mass of small pieces of calcium carbonate. All other conditions stay same. Draw a line on the grid on figure 3.1 to show how the volume of CO2 changes when small pieces of the calcium carbonate are used. So small piece of calcium carbonate mean this time you are going to increase the surface area and there will be more rate of reaction, but yield will be the same. As you know, this line is showing the yield of a chemical reaction, but this line the curved portion is showing the speed of a reaction basically. So speed will be changed. Yield will not be changed. As we are going to use more surface area this time, reaction will start, graph will start from the same point and it will end at this point. But this time the line will be more closer to the y-axis, showing the high speed of reaction. Part C. Student repeats experiment at 20 degrees Celsius. This time, initially he was using basically 25 degree. Initially, he was using 25 degrees Celsius, but now in part C, student repeats the experiment at 20 degrees Celsius. All other conditions stay same. Describe and explain using Pulayan theory how the rate of reaction differ when the temperature of 20 degree is used. So once again, there are the typical points whenever you are going to change the temperature. So number one, I'm going to write in a specific way so as to accommodate my all points. Number one, I'm going to write my points in a specific way that to accommodate all these points in the given space in this paper, in this question. So this is the basic answer, an appropriate answer you can say, and it's going to be have at least three major main points. Number one, he is asking to describe and then explain. So the description is it's a lower temperature basically. Rate of reaction decreases at low temperature. The temperature is going to decrease, so rate will be decreased. Why it is going to decrease? Basically, particle move slowly at low temperature, or you can say it is they are having less kinetic energy. Or I'm going to change it. Or they are having less kinetic energy at a low temperature, and there is less frequency of effective collisions between the particles now. So that is an appropriate answer, that is an appropriate reason, that is an appropriate description to write the to address the questions like that. Part D. A sample of carbon dioxide is put into a gas range. The end of the gas range is then blocked so that no gas can escape. Explain using kinetic particle theory why increasing the pressure in a gas range decreases the volume of the gas and temperature stays same. You know, pressure and the volume are inversely proportional to each other. Again, I'm going to try to write in a proper way. So this is once again, this is an appropriate description of why volume of the gas is going to change by changing the pressure, or the volume of gas is going to change by changing the temperature. So this is all about this paper, this question number 3 of this paper. And now I'm going to switch towards question number 4. Concentrated aqueous magnesium iodide is electrolyte using graphite electrode, graphite main inert electrodes. Predict the product at each electrode, anode and cathode. Again, I'm going to use His rule. I'm using Khizr rule. At the moment, once again, let me check how many different ions are present. Magnesium iodide. So magnesium 2 positive, iodide I1 negative, H positive ion from water, and OH negative ion from water. But this is a concentrated solution, so definitely in this case, iodide ion will be the winner ion. It will move towards the anode. And as far as the positive ions computation is concerned, H positive ion is the winner ion. So H positive ion will go towards cathode and it will change itself into hydrogen gas, because hydrogen ion is a more reactive than magnesium ion, or you can write hydrogen is less reactive element than magnesium element. And this I negative ion, because of having more concentration, because it is in more concentration, so it will move towards anode. So product mean compound iodine. Iodine is supposed to be formed at anode, and hydrogen gas is supposed to be formed at cathode. Molten magnesium iodide is electrolyte using graphite electrode. Construct the ionic equation. Once again, let me explain one thing more, that as we were using graphite electrode, so it means that these electrodes are inert. So it's the first step. Basically, first of all, you should check the nature of electrode. Are they inert or non-inert? Now come toward the second portion, that is B. Molten magnesium iodide is electrolyte using graphite electrodes. Construct the ionic half equation for the reaction at each electrode when molten magnesium iodide is electrolyte. In case of molten, there is no possibility of, there are no any H positive or OH negative ions. So there are only two type of ions, magnesium 2 positive ion and I negative ion. So it's very simple. Again, at anode, there is the formation of iodine. How iodine is supposed to be formed? So this is the general equation. 2 mole of I negative ion or any other group 7 element ion is going to lose 2 mole of electrons, making pure element halogens. It may be Cl2, it may be Br2, it may be I2. And here it is. Now come towards the cathode. These electrons will move towards cathode, in fact you can say, and they will be captured by the positive ion, magnesium positive ion. It's a liquid. Again, it's a liquid. And iodine, you can write it's solid, but there is no need to write the state symbol as they are not asking about the state symbols. So goes to making magnesium solid. You can also write the solid as well. So basically, once again, there is no need to draw the state symbols. Just write the species, balanced species, and so on. And here are these two equations. C. Describe a test for the aqueous iodide ion. Include the observation for a positive result. To test the Cl negative ion, Br negative ion, or any halide ion, basically, first of all, we add HNO3, add HNO3 aqueous, then add AgNO3 aqueous, silver nitrate aqueous. Right. Observation will be yellow precipitate. Yellow precipitate is formed. That is the observation basically, and boom, that's all about this one. Part D, iodide ions reduce manganese 4 oxide MnO2 to Mn2 positive ion. And here is the equation basically. Explain in terms of movement of electron how iodide ion act as a reducing agent in this reaction. So what is happening? Iodide ion, initially it is having -1 oxidation state, and finally it is having 0 oxidation state as it is a pure element. So what is it's doing? It's basically iodide ion is losing electron, right? It's losing electron to initially this MnO2 is plus 4 in oxidation state, and finally after the gain of 2 electron per 1 MnO2, it has been changed into plus 2. So iodide ion is losing electron to MnO2. That is why it is going to behave as a reducing agent. So it's a reducing agent, as it's reducing MnO2 into Mn2 positive one. The next portion state the name of type of reaction that involves simultaneous oxidation and reduction. The oxidation and reduction both collectively, simultaneously, if they're happening in a reaction, then overall that reaction is said to be redox reactions. So it is a redox reaction. Part E. Phosphorus 3 iodide is produced when phosphorus reacts with iodine. Complete figure 4.1 to show the dot and cross diagram for a molecule of phosphorus 3 iodide. Show only outer shell electrons. So you know that I'm going to draw first of all P, 1 bond iodine, 1 bond iodine, and 1 bond iodine over here. As you know, iodine is the member of group 7 element, and it makes normally only 1 covalent bond. Here P is at least is making 3 covalent bond. So generally speaking, I'm going to mark the lone pair. I mean, this P is using 3 electrons, and overall electrons are 5 electron in their last shell, as P is the member of group 5 element. So here is 1 lone pair. So I'm going to write 1 lone pair over here, and here 1 electron from phosphorus, 1 electron from iodine. Here you can say like that, dot and cross, dot and cross. Now come towards this iodine. This iodine is overall having 7 electrons. So I'm going to represent electron of iodine by cross. So 1, 2, 3, 4, 5, 6, 7. Same is the case with other 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is the appropriate structure. First of all, you should draw the structure like that. That is called Lewis structure. Then see where are the bonds, simple bond, and where is the lone pair. So after that, you can change the structure into this one. But what is the dot and cross diagram? In dot and cross diagram, we show all pairs, bond pair or lone pairs in all species. Here, this is a lone pair, and these all are lone pairs. So I have shown over here different lone pair. And what are these? These are the bond pair. These green pair are the bond pairs, and yellow highlighted pairs are the basically lone pair. So this is an appropriate answer, appropriate structure of PI3. Question number 5. A figure 5.1 shows the displayed formula of compound A. This is the compound A that is having carbon-carbon double bond, and it's also having COH group, I mean alcoholic group. Part 1 on diagram 5.1. Draw a circle around the functional group that react with aqueous bromine. You know, Aqueous bromine is used to check the presence of carbon-carbon double bond. That is a typical reagent to check the presence of carbon-carbon double bond, to check the unsaturation, and here it is. So this one is going to react with the bromine. Next, describe the color change when excess compound A is added into the few drop of aqueous bromine. Color of aqueous bromine, initially it is reddish brown. It's a reddish brown liquid, you can say. And finally, it's going to change aqueous, reddish brown liquid. After the addition of compound A, there will be, its color will be fade away. It will be no color or colorless. Colorless. The next one is deduce the molecular formula of compound A. So how to find the molecular formula? How many carbons are there? 1, 2, 3, 4. 4 carbons are there. How many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens are there and 1 oxygen is over here. So C4H8O is the molecular formula of compound A. C4H8O. Compound A is a liquid at room temperature. Describe the motion and separation of the particle in a liquid. So this is once again a typical question. Here we can describe how they are fast, are they regular or irregular, what are the gaps between them, are they moving randomly, is there a random movement, and what is the energy of the particles, and so on. So fast, regular, irregular, gaps, random movement, or no movement, and so on. So here I'm going to report my answer. I'm going to write the appropriate options over here. So basically what they are moving, they are sliding to each other, liquid particles. They are moving randomly, sliding randomly. So sliding or moving. There are small gaps or they close together. So these are the appropriate reason. They are sliding randomly or moving randomly. There is random movement basically. There's a random movement. And gaps, separation mean they are very separated, or they are separated, and how close they are basically. So they are close to each other. There are small gaps between the molecule, and it's a gap. Question, the next part B, show the structure of compound B. This one. Compound B is polymerized. Draw 2 repeat unit of the polymer formed when compound B is polymerized. First of all, I'm going to rewrite this molecule over here. Let's see over here. Carbon-carbon double bond is, first of all, I'm going to write it over here. First of all, you should write carbon-carbon double bond. Then one carbon is having hydrogen and the same carbon is having CH3. So I am going to write it over here like in form of condensed formula. Yes, you can do it. The next thing is, again, this carbon, one atom is hydrogen or one group is CH3. So I'm arranging all these atoms around carbon-carbon double bond like that. So I'm writing basically the group above or below the carbon-carbon double bond. I wrote above or below, above or below the carbon-carbon double bond, not from, before and after. There is nothing. So this is the way that, I mean, it's a way to write, you can say. Now the next thing is I'm going to making copy and paste. So I have three basic monomers lying over here in front of each other. Now what I'm doing basically, I'm removing this bond and shifting it towards onward over here. This bond will be shifted over here, this will be shifted over here. So here will be one bond, new bond, here will be the new bond, and here there also will be the new bond. So now I'm going to eliminate the old double bonds and arrows as well. So this is the three repeating unit structure. And he is asking just to write the two repeating unit. So I'm removing one repeating unit, the third one. And this is the basically a two repeating unit, and it is essential to show these line as well and the continuous backbone chain of the carbon atom. So this is the structure of polymer for this compound B. C. Describe two environmental challenges caused by the disposal of plastic. So, disposal of the plastic make the harmful gases on burning, and it's in ocean it can cause accumulation of the plastic. It may generate the landfill site. So first of all, so on burning, they are going to give the different toxic gases. One is the common, one of the common is CO. The second thing, as they are not water insoluble, so they can cause accumulation of the plastic in oceans because of their water insoluble nature. So that's all about this one, this question number 5. Question number 6a, steam reacts with the carbon to produce carbon monoxide and hydrogen. So steam react with the carbon to make carbon monoxide and hydrogen. Steam plus carbon, this is the sign of reversible reaction, carbon monoxide and hydrogen. The forward reaction is endothermic. Part 1a, A1, explain in terms of bond making and bond breaking why this reaction is endothermic. Why this reaction is endothermic? And it's having 2 marks basically. So first of all, I'm going to write the simple normal sentence. This is, you can say, one of the most oftenly asked question, and the one sentence is bond making is exothermic, bond breaking is endothermic. For 1 mark we will write this sentence every time. So this sentence is for 1 mark. Bond making is exothermic while bond breaking is an endothermic or endothermic process. Now the next sentence will be with respect to the energy released. What is the next sentence? As this reaction is endothermic, it is an endothermic reaction. So in term of energy, the second number will be in term of energy. The second point will be in term of energy. That is for second point. You can also write another point, a third point, an extra point you can say, that is in this case, as this is is an endothermic reaction, so stronger bonds are being broken than the bonds formed. So, this is the appropriate way to write the answer for this question. Now, the next one, part 2, the transfer of thermal energy in the chemical reaction is called enthalpy change. Write the symbol for the enthalpy change, include sign for endothermic enthalpy change. You know, delta H is said to be enthalpy change and its sign is positive in this case, in case of endothermic reaction. Part B, carbon monoxide, water, carbon dioxide are formed during incomplete combustion of carbon containing fuels. Name one other substance formed during incomplete combustion of the carbon containing fuel. So that is basically carbon. Carbon, that is sometimes known as soot. Overall basic and exact answer is carbon. Basically on incomplete combustion, there is formation of carbon, carbon monoxide, carbon dioxide and H2O water. So here in this case, this carbon, this C is the appropriate option. State 1, adverse effect of carbon monoxide. That is once again a typical question. Carbon monoxide is a toxic gas and it may lead to the death. So it's a toxic or poisonous gas. It is a toxic gas. Next one, hydrogen is used in a fuel, hydrogen oxygen fuel cell. Describe two advantages of the hydrogen oxygen fuel cell with gasoline or petrol engine. So this is again a comparative question. It's more efficient. With respect to the petrol engine. And the second one is it's not making any greenhouse or the toxic or pollutant gases. No pollutant gases are formed over here. I mean, no carbon dioxide gas is formed, no pollutant gases are formed, just water is being formed and so on. That's all about question number 6. Question number 7, dilute hydrochloric acid react with aqueous sodium carbonate, and here is the equation. 2 mole of HCl is going to react with sodium carbonate to give 2 mole of NaCl, 1 mole of H2O and 1 mole of CO2. A student titrates 20 centimeter cube of 0.025 mole per dm cube of sodium carbonate with dilute hydrochloric acid using methyl orange as an indicator. A volume of 15.5 centimeter cube of dilute hydrochloric acid reacts exactly with 0.025 mole of sodium carbonate. Calculate the concentration in mole per dm cube for dilute hydrochloric acid. So this is an acid-base reaction, acid-base titration you can say, and here we can apply this formula, our typical formula. C1 into V1 over N1, that is equal to C2 into V2 over N2. This portion, this left hand side, let's suppose it is for acid, let's suppose it is for HCl, and this right hand side, let's suppose it's for sodium carbonate. So in this case, this is the concentration of acid, this is the volume of acid, and this is the number of mole of acid from the balanced chemical equation. This is the concentration of sodium carbonate, this is the volume of sodium carbonate, and this is the mole of sodium carbonate from the balanced chemical equation. So let's see over here. First of all, what is the volume of sodium carbonate and concentration of sodium carbonate? So concentration is 0.0250 into volume is equal to 20 and divided by mole of sodium carbonate is equal to 1 is equal to concentration of HCl is to be calculated. So C1 into what is the volume of HCl that is being used is 15.5 divided by what is its mole, that is equal to 2. So C1, the concentration of the acid is equal to 0.025 into 20 into 2 divided by 15.5, and the answer is 0.0645. State the color of methyl orange in alkaline solution. Methyl orange is having basically 3 colors that can be memorized by ROY: red, orange, and yellow. So in acid it's red, in alkali it's yellow, at pH is equal to 7 it's an orange. So he is asking in alkaline solution, so it will be yellow. Write the formula of the ion present in aqueous solution of an alkali. All alkalis are having a unanimous ion, a type of ion that is called OH negative ion. OH negative ion, aqueous ion. There is no need to write the aqueous, however I am writing aqueous ion. Next one, calculate the volume measured at RTP of carbon dioxide produced in centimeter cube when 2.6 gram of sodium carbonate react with excess HCl. And here is the equation. So in this question we are supposed to measure the volume of CO2 in centimeter cube at RTP. So you know what is the volume of a gas of 1 mole at RTP in centimeter cube. So 1 mole of a gas is equal to 24,000 centimeter cube at RTP. Now the basic thing is, the basic main question is, the basic obstacle is to find the mole of carbon dioxide in this case. What is given? Sodium carbonate is given, this HCl is in excess, and this is the limiting reactant. So from this balanced chemical equation we can see that 1 mole of sodium carbonate is going to give 1 mole of CO2. So there is 1:1 mole ratio between Na2CO3 and CO2. I'm going to change this mass into mole. How to change mass into mole? You know, mole is equal to mass over mR. So 2.65 gram divided by what is the overall mR of sodium carbonate, that is 106 gram, and the answer is 0.025 moles. You know there is 1:1 ratio between Na2CO3 and CO2, so the same mole, 0.025 mole of CO2 will be there. So 1 mole is equal to this volume, and if I'm using this mole of CO2, the volume will be 24,000 multiplied by 0.025 mole, and the overall answer is 600 centimeter cube. Part D, define the term strong acid in the phrase strong acid. Term strong. What do you mean by the strong? Strong mean the acid which completely ionize in water. Acid which completely soluble or completely ionize, which an acid which completely ionize ionizes in water. So which completely ionizes in water is called a strong acid. Next one, E. Oxide of the nitrogen contribute to the acid rain. Said one other adverse effect of oxide of nitrogen. Except the contribution of, except the acid rain, the next effect, the bad effect, is it creates respiratory system problems, smoke, photochemical smoke, and they damages the lungs and so on. So you can write they create respiratory problem. Next one question, the part basically oxide of the nitrogen are removed from the car exhaust by catalytic converter. Complete the symbol equation for the reaction that occur in catalytic converter. This is the carbon monoxide, this is the nitrogen monoxide, and what are the outcomes after passing these gases from catalytic converter? The outcome is CO2 and just N2, two less harmful gases, or environmental friendly gases respectively. So I'm going to put 2 over here for the sake of balancing, and this is the balance equation. So that's all about this question number 7. Come towards question number 8. The equation for the reaction of carbon monoxide with hydrogen at high temperature in a closed container is shown over here. Carbon monoxide is going to react with H2 to make methanol, and this is again reversible reaction. The forward reaction is exothermic. Predict and explain effect, if any, on the position of equilibrium. It's a typical question once again that is taken from the rate of reaction when pressure is increased and temperature remains constant. So basically they are asking the effect of pressure on equilibrium, on the position of equilibrium when all other conditions are almost same or the constant. And this reaction is exothermic and so on. But pressure doesn't concerned with the exothermic or endothermic nature. It basically, the effect of pressure is concerned with the number of mole present on both sides. So let me check. 1 mole, 2 mole, overall mole is equal to 3, goes to, it is equal to 1. So the ratio is 3:1. When we are going to increase the pressure, when the pressure is going to increase, equilibrium will be shifted toward that side where there are less number of moles. So basically, number 1, predict and explain what will happen. Basically, more methanol will be formed or equilibrium will be shifted towards the right hand side. Position of equilibrium will be shifted towards right hand side. Why this is happening? Why is this so? The reason is there are less number of moles on the right hand side, less number of mole of gases. The mole of gases are important. Mole of gases are important, as on right hand side there are less number of moles of gases. Second one, predict and explain the effect, if any, on the position of equilibrium. Once again, when the temperature is increased, the pressure is now this time is constant, and this is just for 1 mark. So yes, there will be effect of pressure, because this reaction is, there will be effect of temperature, as the reaction is exothermic. So if the reaction is exothermic, on raising the temperature, equilibrium will be shifted towards backward. I mean, raise in temperature or increase in temperature favors the endothermic side. If the forward reaction is exo, it means that the backward reaction is endo, and increase in temperature favors the endothermic side. So POE, I mean position of equilibrium, will be shifted towards left hand side, as reverse fraction is endothermic. Reverse fraction is endothermic, as the reverse fraction is endothermic. Part B, methanol react with ethanoic acid to produce an ester. Name the ester and draw its displayed formula. Name the ester, you know what is the name of acid. The acid is basically ethanoic acid, and methanol is the alcohol that is going to react. So the name is written from alcohol to acid. I mean, first of all, I will write methyl, then I will write ethanoate. So name is methyl ethanoate. So the name is methyl ethanoate. The displayed formula again is simple. Methyl, this is the methyl group. It is oxygen, carbon, double bond oxygen, and here is the carbon, and this is here are 2 carbons for ethane, and is 1 carbon for methane. I mean, this is overall methyl ethanoate is the displayed formula of this ester, and I'm removing these lines, I mean box and etc. So that is exact formula. Part C, methanol is a member of alcohol homologous series. Describe 2 general characteristics of the homologous series. Basically, homologous series is basically having the same functional group. Number 1, you can say. Second things, they are having same general formula, and each member of the group is differ by CH2 group. As we trickle down the series, physical properties are going to change, and all members of the homologous series having same chemical properties. So first of all, same functional group, all members having same functional group, all members have same functional group, all members have same general formula. Each adjacent member is differ by CH2 group to the other member, by CH2 group to another member, and so on. So this is all about the question, this one. So this is all about this question, question number 8. Now come toward the next question. Next question is question number 9. A. Table 9.1 show melting point and relative electrical conductivities of three elements. Melting point of calcium, melting point of carbon, diamine, iodine. Relative electrical conductivity of the solid, it's good, it's poor, diamond is poor conductor of electricity, and iodine is also poor. What is the question? Question is use idea about structure and bonding to explain the difference between the melting point. So we are going to compare the different structure and bonding of diamond and iodine to justify the difference of their melting point. There's a huge difference between the melting point of diamond and iodine. You can see it over here. So first of all, what is the structure of diamond and what is the structure of iodine? Basically, the structure of diamond, in diamond there are each carbon atom. In diamond, each carbon atom is making 4 strong covalent bonds, and the structure of diamond is joint molecular structure or macromolecular structure. Giant molecular structure or macromolecular structure. What is the structure and bonding in iodine? Iodine is a simple covalent molecule and it is having weak van der Waals bonds or van der Waals forces. And the third one point is for the comparison. As diamond is having strong bonds, so it needs more energy, and iodine, between the iodine molecule there are weak van der Waals forces, so that's why it can be easily melt down. The next one portion is the difference in the electrical conductivity of the calcium and iodine. So number 1, I'm going to write my points in a specific way that to accommodate all these points in the given space in this paper, in this question. It has mobile electron which can move freely, or this calcium can delocalize its valence electron, but iodine cannot delocalize its valence electron. So calcium can delocalize its valence electron as it's a metal, but iodine is a non-metal and it cannot delocalize its valence electron. Part B, diamond and graphite are different form of the carbon. Explain in terms of its structure why graphite is lubricant. The structure of graphite is basically a layered structure. There are so many layers and layers can slide to each other. So the first thing is, in the graphite the atoms are arranged in form of layers and these layers can slide to each other. So that's why this graphite is acting as a lubricant. C. A compound of sodium, iodine and oxygen contains 11.62% sodium, 64.14% iodine and 24.24% oxygen by mass. Deduce empirical formula of this compound. So again, this question is from stoichiometry and calculations. So what is the percentage of sodium? It is 11.62%. What is the percentage of iodine? Is 64.14%, and oxygen is 24.24%. It's a sodium, it's iodine, and it's oxygen by mass. So divide by the mass AR of these elements. 23 is the AR of sodium, and what is the mass of iodine? That is 127. What is the mass of oxygen? AR of oxygen, that is equal to 16. Now come towards the answer. The answer of the sodium is equal to 0.505, and the answer of oxygen, answer of the iodine is same, 0.505, 0.505, and the answer of oxygen is equal to 1.515. So the third one point is dividing by the smallest answer, 0.505 divided by 0.505 divided by 0.505. So that is equal to 1, 1, and that is equal to 3. So sodium is equal to 1 and iodine is equal to 1, but oxygen is equal to 3. So NaIO3 is the answer of the empirical formula of this one. That's all about this paper. Don't forget to subscribe my channel, hit the bell icon and share it with your friend. Thank you very much. Have a nice day.